Another new term, resistance, with symbol capital letter R. So when an electrical component, example your bulb, is connected in a circuit, this component will actually resist or hinder the flow of electric charges. So in the electric component, the resistance to the flow of the charge is similar to how a narrow channel resists the flow of water. So for example, if this is your bulb or your electrical component with resistance, you find that when the electric charges are trying to flow through, there's a narrow channel that resists the flow of the electric charges. So the higher the resistance in a component, the higher the potential difference or energy needed to move electric charge across 2 points through the component. And resistance can be expressed as a ratio. So the resistance of a component is the ratio of the potential difference, your capital letter V, across it, to the current, capital letter I, flowing through it. And the SI unit of resistance is the ohm. Okay, this is how you write the symbol for ohm. And the greater the ratio of V to I, the greater the resistance. So we can actually make use of this calculation or formula triangle to help us to calculate the values of V, R, and I when necessary. Okay, so we learned that resistance is the ratio of the potential difference to the current. So R equals to V over I. So if you want to find R, you can cover R and then you see V over I. Next one, if you want V, then V equals to I times R. And if you want to find I, cover the I, you have V divided by R. So these are the three formulas that we can use to do the calculations of resistance, potential difference, and current in your electric circuits. Now, most electrical circuits contain components which have known or fixed resistances. We call them fixed resistors. This photograph shows some examples of fixed resistors. Each one of them have different colored bands that indicate the resistance of the resistor. Now, if a circuit contains only fixed resistors, then the resistance of the circuit cannot be changed unless we change the resistors themselves. Okay, we can also change the resistance of the circuit if we have variable resistors. Okay, but we are not covering that in this topic now at the moment. Right? Now, how the circuit components are arranged in a circuit actually affects the resistance of the circuit. So if a circuit contains only fixed resistors, we can adjust the resistance of the circuit by connecting your fixed resistors in different arrangements, okay, whether in series or in parallel. Okay, so the symbol to represent a fixed resistor in a circuit diagram is just a rectangle box, okay, with the wires connecting to it. Now let us look at an example of how the arrangement of circuit components will affect the resistance. So in this electric circuit here, the light bulb is connected in series with a fixed resistor and a cell or battery. And in this case, the light bulb will light up. Okay, next, we try to add a second resistor to the electric circuit, arranging the two resistors in parallel. And we find that in this circuit, the resistance is decreased. Hence, the current that flows through the light bulb increases and the light bulb becomes brighter. However, If we have added the second resistor in series, this would actually increase the resistance in the circuit. Hence, the current that flows through the light bulb decreases and the light bulb becomes dimmer. So you see that if I add the resistor in parallel, the light bulb becomes brighter. But when I add the resistor in series, the light bulb becomes dimmer. So what we have seen in this example here is that when the resistance decreases, the current actually increases and the light bulb becomes brighter. Okay, so the greater the current in the circuit, the brighter the light bulb. And to have greater current, you must have lower resistance.